we're going to talk about linear regression. Let me go a little bit back here, and then let's try to have a little bit intuition over here. Now, for a simple definition that I gave over here, right, that linear regression, right, linear regression is used for finding a linear relationship, right? So I'm going to digest this and see what I mean by this, right? So what we're saying over here is that a linear regression will help us to find a linear relationship that is existing between a target variable, right? And I'm going to explain this to you, what a target variable means. And if you've watched the previous videos, I'm sure you have a little bit intuition about what a target variable is, okay? And we're going to actually see it in this particular video as we progress to the lab, right? So it'll help us to find the linear relationship that is between a target variable and one or more, right? One or more predictor variables, right? So let's go to the whiteboard and see what we mean by this, right? Let's go to the whiteboard and then see what we mean by that. Okay. So what we are saying is that if you remember in the last video, we talked about GDP of a country, right? We talked about the GDP of a country. So let's take that and then see what we talked about in that class. So GDP of a country, we say that it gets influenced by so many factors, right? Maybe including the workforce of the country, right? Including the workforce of the country, right? Including the workforce of the country, plus maybe the educational level of the country, right? Maybe the educational system, right? The educational system of the country, right? Maybe the educational system of the country. All right, and then some other factors that might also affect it, right? Some other factors that might also affect it. Maybe the various innovations in the country, right? The various innovations, right? The various innovations in the country, right? Plus some other factors that we cannot actually list all of them here. Okay, so what is happening here is that if we want to find out, let me zoom a little bit here. Yeah. If we want to find the relationship that is existing, right, among GDP and all these factors, right, GDP and all these factors, if we want to find the relationship here, okay, if we want to find the relationship here, we can say that, okay, this is our target here, right, this is our target, this is what we want to predict. We want to predict the GDP of a country based on these factors, right? Based on these factors. So can we find a linear relationship between GDP and all these factors? Can we do that? Can we find a linear relationship that is between GDP and all these factors? Okay. So in order to find this, right, that's when linear regression comes into play. All right. So that's when the linear regression. So you can think of this GDP as say y, right, and then we will use some function to actually find a relationship between these. So think of this x as these variables: the workforce, the educational system, and then the innovation of the country, right? So think of this x as these variables, okay? So we will try to find the relationship between this x, right, and this y, right? So you can think of this y as the GDP, you can think of this x as these workforce and the educational system and all these factors, okay? So we try to find the relationship between this x and this y, okay? So that's what linear regression will help us to actually do, okay? That's what linear regression will help us to do. Now, okay, so let's take this a little bit down over here and then try to find, let's use some visual representation to get to understand what linear regression is about, okay? So now let's say that we have this. Let's say that we have this. Okay, so let's say we have this one, right? Let's say we have this here. Let's say we have this here. Now we can actually represent this part, right? We can say that this is our y-axis, right? This is our y-axis. This is our x-axis. Okay. So if you want to think of it in terms of dependent and independent, right? So our y, right? Our y is always a dependent variable. Remember that we say that GDP is dependent on these factors, that's workforce, educational system, right? And GDP is our y, right? So that's a dependent variable. So you can think of this y here, right, as a dependent variable, right? You can think of it in that way as a dependent, right, as a dependent variable. Okay, you can think of it as a dependent variable. Then this x represents these factors that you can see over here, right? So this one here becomes the independent, right? It becomes the independent variable, right? You can think of this one as the independent variable. Okay, so can we now find the relationship between the dependent variable and then the independent variable? Can we now do that? Okay, now let's just take some dummy example over here, right? Let me just create some dummy example over here so that it will things will become clear as we progress. So let's say we have x to be 1, y to be 1, x to be 2, y to be 2, x to be 3, y to be 3, x to be 4, y to be 4, x to be 5, y to be 5, right? So let's just take this one. I think it's okay now. Okay, now we are saying that if x is 1, y is 1. Okay, so now let's plot some let's put some labels here, right? So let's say here is 1, we have 2, we have 3, we have 4, we have 5, we have 6, right, and so on. Okay, we have 6 and so on. Then over here we have 1, right? We have 2, we have 3, we have 4, we have 5, we have 6, we have 7, and so on. Okay, now what we are saying is that if x is 1, y is 1. So if x is 1, y is 1. So somewhere maybe they will meet somewhere here, right? That's where we can plot at that point. If x is 2, right? If x is 2, if x is 2, y is also 2, right? So s is 2, y is 2. So they will meet somewhere here, okay? And then if s is 3, y is also 3. So this one and that and 3 will meet somewhere here. X is 4, y is 4, right? So both of them will meet somewhere here, okay? X is 5, y is 5, so they will meet somewhere here, okay? They will meet somewhere here. Now, can we draw a line here, right? Can we draw a line here to connect to these points, right? You can draw a line to connect to these points, right? You can do that. We can connect to these points. Now, we have a relationship. Now, we have a relationship between y and then x over here. Okay, we have a linear relationship between y and x here. What we are doing is that if you see the numbers that we have in here, x equals y, right? Whatever x is 1, y is 1, x is 2, y is 2, x is 3, y is 3. So we can we now write y equals x, right? Can we do that? Can we write y equals x? Okay, we can do that, right? Because whatever value x is, the same thing y is also, okay? If s is 2, y is also 2. If s is 3, y is also 3. Okay, so can we do that? Now, what happens over here is that this, remember that for every number, right? If we write 2, right, we can say that 2. We can say that 2 times 1 is still equal to 2, isn't it? If we write, say, 100, right? If we write 100, right, we see 100 times 1 is still equal to 100, isn't it? So we can imagine, right? We can imagine that there's 1 here, right? Say 1 times x, which is still the same thing. It doesn't actually make any sense, right? What I'm trying to tell you is that for any change in x, for any 1 change in x, right, y changes the same way, right? So you can trace this, right? We can actually trace this on the graph that we've plotted here, right? When we can actually say that, okay, if we change x from 2 to 3, right? That is moving from 2 to 3, right? What will y do? Y will also change from 2 to 3, right? Y will also change from 2 to 3. Okay, so the change in x, right? The change in x over here, right? The change in x, right, is the same change in y. Okay, is the same change in y. Okay, the change in x is equal to the change in y. All right, okay, so we can say that the change in x is equal to the change in y. Okay, the change in x is equal to the change in y. So that's basically what I'm trying to say over here. So if you change x by 1 unit, y also changes by the same unit. Okay, so but that is limited to this example that we're given, right? In different examples, it might not be the same thing, right? So in order to be the safer side, right, let's represent this 1 here, right, with, say, just another letter, right, maybe m, right? So we could have x, right? We could have mx. Okay, so in case we have a different example, and then that example is not the same thing, right? It's not in the same way where we can have this m to be 1, right? Maybe this m could be 2, or it could be 5, or something like that. Okay, maybe if you change x by 5 units, right, y is actually going to change by a different unit. Okay, so it's not always going to be the same thing as we've given this example over here. So we can represent this 1 here with m. Okay, now if you see the graph that we've plotted here, remember that this graph is passing through the origin, which is 0, 0, okay, which is 0, 0. That's where this line cuts the x and on the y-axis together over here, okay, or even if you want to think of it as only the y-axis, it cuts it at the 0 point. So even if we want to add that place or that point where the line cuts the x-axis, is going to be 0, okay, it's going to be 0, so it will not have any impact over here. Right, let's change this example too, and then see a different example where we can actually see that this curve might shift, right? So this curve might shift, okay? So this over here we see that it's passing through here, right? But if we can find it in a way where this m, right, if this m is not 1, right, it means that this one will not pass through here, right? When the change between these variables are not the same, then this curve is either going to shift up, right, where if we have the m to be greater than 1, right, it's going to be shift up. And if we have this m to be less than 1, then the curve might cut this part, right, it might shift down like that, okay? So let's see a different example so that we get to understand this very well. Okay, so we have here x, y, right? So let me do the same thing over here, right? So we'll be having our x here, then we'll be having our y here, okay? Let's take this and then take a different example over here. So let's say we have 0, we have 1, we have 1, we have 2, right? We have 2, we have 2 here, then we will have 3 here. So whatever x is, right, I'm increasing it by 1 to give that to y, okay? I'm increasing that by 1 and I'm giving that to y. Okay. So let me continue with this one here. Okay, so now if x is say 2, then y will be 3. Okay, if x is say 3, then y will be 4, right? So whatever x is, I'm increasing it by 1. Okay, so if x is say 4, then y will be 5. Okay, now let's plot this again. Let's plot this again over here. Right, let me draw it again so that we can actually plot it. So I'm just going to use a freehand sketch to plot this, right, and not drawn to scale. So now we have our y, right? We'll be having our y here, then we have our x over here, right? We have our x over here. All right, now let's try and then plot this. Let's try and then plot what we have over here. Wait, let's try and then plot it. Now we'll have our 0 here, right, which will be the origin, which is 0, 0, just like we are seeing up here, right, just like we see over up here. Now we have this 0, 0. Now let's try and then label this. Let's say this is 1, this is 2, this is 3, this will be 4, right, this will be 5, this will be 6, and so on. Okay, this will be say 1, this will be 2 here, there will be 3, right, there will be 4, there will be some 5, and so on. Okay, now if we see the table that we have, when x is 0, we have y to be 1, right? So the point is actually going to be plotted here, right? When x is 0, y to be 1, right? When x is 1, right, y is 2, so both of them are going to meet somewhere here. When x is 2, right, when x is 2, then y is 3, right? So that's going to be somewhere here, right? That's going to be somewhere here. And when s is 3, right, y is 4, right? S is 3, y is 4, so we can plot that one here, right? We can plot it here. When x is 4, y is 5, right? So 4 and then 5, right? 4 and then 5, somewhere here. Okay, so we can continue like that, right? So when s is 5, y will be 6, right? So if we want to continue like that, we can also continue with that. All right, now if you see this one, you see where if we try to draw the line, right? If we try to draw the line to cut through this point, right? To cut through this point. Now you see that this time it's not passing through the origin as we're having over here. Okay, as we're having over here initially. Right now, which means that we need to actually modify our equation. We need to modify this equation that we have here, right? We need to modify this equation that we have here. Otherwise, if we want to make some predictions, right? Remember that we say that linear regression will help us to make feature predictions, okay? It will help us to make feature predictions. So we need to actually make adjustment over here. If we say that we are going to use the relationship that we had earlier on, right? Where y equals mx, right? And now if we say that, if we use this, right? In this case, our change in y is actually 0. I mean, it's actually 1, right? That is, if y If x changes by 1 unit, right, if you see the difference between this and that is 1, difference between this and that is 1, right? So if x changes by 1 unit, y also changes by 1 unit, okay? If x changes by 1 unit, y changes by 1 unit, okay? Now, if we use that relationship and we say that we are going to use this, so our y, right, our y will be equal to, say, m here, right, or m here, and then what will be the difference between, what will be the x value? Let's say our x value at first, right, is 0, right, which means that we're going to have this m times 0. So if this m is 1, then we're going to have y to be 0. But in this case, our y is 1, which means this is not actually helping us to make that correct predictions. Okay, if we say that our x is 1, right, so let's try and see if we can predict y to be 2, right? Now, if we say that, right, if we do that, and then we put say 1 times, that is 1 for m, and then we use the x. In this case, our x value is 1, right? So 1 times 1 is actually 1, so our y is supposed to be 1. But if you see, the actual value there is 2. Okay, so now you can see this one is not working. Okay, after we chose a different example, you can see that it's not working. If we move further and then we choose, say, our x, right, so this one is for m, right, this one is for m. Now if our x here is, say, 3, right, if our x is 3, then we are going to have y to be 3. But if you see what is there, right, the actual value here is 4. So now if you see what is happening here, is that it's just like whatever value that we have here, we need to add 1 to it, right? We need to, so if we add 1 to it, we can see that y will be 4. I mean, y will be 2, right? When x is 1, y will be 2. It's the same thing that we have. When x is 1, y will be 2. Now, this thing will work for us. So if we go to our equation and we modify it and add 1 to it, right? We add 1 to it, we can see that this time it will work for us, right? Now, if we take, say, our y equals, our m is 1, right? Our m is 1. Now multiply by, if we pick, say, our x to be, say, 2, right, 2 over here. Now we have plus 1 over there, right, plus 1 over there. Okay, now if we do it in that case, right, if we do it in that situation, you can see that, okay, y equals, right, y equals 1 times 2, right, 1 times 2 plus 1, right. So in this case, we are actually going to have we're going to have 3, right. We're going to have 3 as our output, and that is the same thing that we have here. When x is 2, when s is 2, our y is 3. Okay, when s is 2, our y is 3. So it's the same thing that we are actually having over here. Okay, so now you can see that this equation that now we are using is working for us for this particular problem. All right, for this particular problem, this equation is actually helping us. Okay, for this particular problem, this equation is actually working for us. Now, what we can actually do, right? What we can actually do over here, okay? So we can see that when our y is equal to, our x equals to 2, now we have our y to be equal to 3, which is the same thing that we have in here. So this equation is actually working for us perfectly. Now, what we can do is that in different situations, right? So as we did earlier on, and then we generalize this one to be m, right? In the different situations, this one is not going to be the same, right? In this particular example, we can see that this line is cutting the y-axis at 1. So this line could cut the y-axis at any point, right? At any point. So this one becomes the y-intercept. Okay, this one that we are adding to the equation here becomes the y-intercept. So if we pick the equation again, right, which is now y equals, right, y equals m, right, m here, and then our x, right, plus the one that we have. Now, can we now generalize this one too, right? Can we now make it a general, just like we made the m, right? The m is nothing but the slope that we discussed earlier on, right? If we go a little bit up, right? If we go, yeah, and the m here is nothing but the slope, right? It's nothing but the slope that we found over here. Now, can we make a generalization just like we did for the m, right? So now if we take this, right, instead of 1, we can just represent it with just a different letter, maybe c. Okay, so that this equation will generalize for us in different examples, right? Because we just took this example and it's working for us, and this line is actually passing cutting the y-axis at 1, right? And that's why this one is working for us. If we take a different example where this line cuts the y-axis at, say, 2, right, this is not going to work. Okay, so if we have a different example, no matter where the line is cutting, right, wherever it's cutting, we can place it over over here if we generalize it. Okay, so now this one that we have over here, okay, this one that we have over here becomes the equation of Li. Okay, this becomes our linear regression equation. Okay, this one becomes our linear regression equation. Okay, this one becomes our linear regression equation. Okay, it becomes our linear regression equation over here, which is y equals mx plus c. All right, that becomes our linear regression equation. So this m here that you're seeing, right, this m here that you're seeing, right, if I should dissect this, let me use this one. Okay, so the y here is our target, right, the y is our target, right, the m here that you can see, right, this is the slope, right. That is how y changes when you change in the x value, right? How much y changes when you change the x value, right? And then this c here becomes the y-intercept, right? That is where the line cuts the y-axis. Okay, so that becomes our linear regression equation. All right, we're going to see this when we get to the code, how this line is actually going to be plotted, right? Just like we did a freehand sketch over here, how it's going to be plotted. Now, this one, right? Remember that we're doing this only in 2-dimensional space, right? Which is just like that, right? Now, if we pick different values of x, right? Let's say we have y, right? Let me bring my black. Okay. So let's say we have y over here, right? We have y over here. Now, instead of just x, right? Let's say we have several variables, right? Just like the GDP, right? So GDP is having different variables that are that we can use to actually determine the GDP of a country. Okay, there are several factors over here which is helping us. So you can think of this workforce, right? You can think of it as X1. You can think of this educational system as S2. You can think of this innovation right here as S3, right? You can think of other variables, so it could go all the way to maybe S10, S20, right? Several variables that we can actually have over here. Okay, so the same thing that we're trying to also say over here. Now we have only one variable. What if we have more than one variable, right? Let's say we have 2 variables, right? So let's say we have X1, right? So let's say we have X1, and then X1 will have it's m, right? So let's represent it with m1. Then we have another variable which is say x2, right, which is also be having say m2, right? So and then don't forget we have our constants. Okay, so if we have 2 variables which are helping us to actually draw the relationship or trying to predict this outcome or target variable, right? If we have two variables here, maybe the food the person eats, right? Maybe how well the person exercises, right? So all these are factors that will help us to predict the weight of the person. Okay, so let's think of it that way. Maybe one represent the food, right? The eating habit of the person, the exercise habit of the person. Okay, so all these are things that are helping us to predict the weight of the person. Okay, now if we have it in this way, right? If we have it in this way and we want to plot this, right? Remember that in this case, this plotting, we're only having one x, which is helping us to predict the y over here. Now, if we have it in this way, what is going to happen is that you might have your y already, right? You might have your, and then the original x, right? So in this case, we have the x1 over here, right? We have the x1 over here. So now we have another x. So maybe that one could also be plotted over here. So that is going to be x2, all right? That's going to be x2. Now, if we try to actually plot this, right? So maybe we can find it to be something like that, right? Maybe we can I think this one just messed up. Okay, so let me do it this way. So we can find it this way. Pardon my handwriting over here, right? Okay, now we can see how this is going to be plotted, right? So this is more of a 3-dimensional space, unlike this one where we're having it in only 2-dimensional space, right? Unlike this one that we plotted earlier on, which was only in 2-dimensional space. Okay, so in this case, if we have it in this case, right, then we refer to this as a plane, right? Now you are in a plane, right? You've moved from the just 2-dimensional space, so you can now think of this as a plane, right? And you have more than this, right? If you have more than this, maybe maybe more than two variables, I mean, right? And then you have maybe m1 x1 plus say m2, right, x2, right, plus maybe m3, right, x3, right, all the way up, right? Don't forget that you have your c, right? So plus, then finally plus your c. Okay, finally you have it plus your c. So what is actually happening over here is that we've moved all the way from even the three-dimensional space to a hyperplane, right? To what is referred to as the hyper plane, right? To what is referred to as the hyperplane. Okay, so just take note of that. We'll be seeing this as we progress in the course. Okay, so now we've moved from just a plane to a hyperplane, just from the equation of a line to a plane to a hyperplane. Okay, now what we're going to do right now is to see a hands-on practice of this linear regression, right? You're going to go to the lab, and then with whatever intuition that we have over here, we're going to put it into practice. Okay, so let's move on to the lab, right? Let's move on to the lab and let's see what we are going to do over here. Okay.